got his degree here in computer engineering. With 40 years of experience in Silicon Valley, Chris has seen almost all of it. So he spent many years after college in the developing field of enterprise software and also data storage providers. One of the companies he helped lead, Simply Continuous, was the first recovery service provider for the small mid-sized market. He was a worldwide lead on private cloud solutions for NetApp, running cloud and IT as a service strategies for 3 years before joining Hewlett Packard and later HPE Enterprise in 2013. Chris spent about 11 years there, and his focus was enterprise solutions, so taking all of the things HPE builds and putting them together in ways that solve enterprise business problems. His final assignment before his transition was HPE's private cloud AI solution, which is a combination of foundational infrastructure and the full stack of software to enable the AI on top. In addition to Chris's industry leadership, he holds 8 patents, and then he also serves on our engineering advisory board here at SJSU. So with that, I'll turn it over to Chris.
All right, thanks, Cheryl.
Yeah.
And I haven't decided whether to call it retire or not, so I'm calling it on LinkedIn unretire, and it's at least caused a lot of people to send me a note saying, what? And to be honest, I'm still figuring it out. It's kind of funny because it's actually a little bit trickier talking to a group like this than when you have an auditorium with 4,000 or 5,000 people in it. And when you go to big companies, more and more often, the ask for someone like me, whether I'm effective or not, is up to the audience. But the audience becomes anonymous at that point. It's not personal. It's not intimate. And so all I got to do is make sure I don't do something like insanely stupid, and it'll be a good. I also would usually have a staff working on my slides, so you'll see homemade slides today, and it looks like duct tape, and you'll find typos. When and how long do I have? The lunch hour,
yeah,
or maybe a little.
Yeah, including Q&A up until noon, or up until 1.
Up until 1. Okay.
Yeah.
All right. So
Yeah, and
we'll see.
I'll just say for the students, if you want to join, you're already eating, but if you want to join lunch after, we've got some lunch upstairs. We can accommodate everybody.
Oh, great. So, so when I thought, what could I possibly have to say to some students here that would self-select into coming into a session like this on their lunch hour, meaning you're probably already pretty darn smart, likely liable to know a lot more than I do about some of the things we're talking about. What I do when I'm in that kind of situation is I don't try to pretend I'm going to come in and tell you more about AI or more about quantum computing or more about anything than you might already know. But what I can contribute, maybe, is a little bit of context. So that you can take all of this incredible detail that you're learning, all this incredible brain power that you possess, the energy. And what I find is some of the brightest engineers, if they don't really know why they're building something, whether it's their career or a product, you kind of don't know if you built the right thing or not. It's like you just went to the garage, found some stuff, I'm going to build this, and then you wander around the world seeing if it works. It can happen with your career. It can happen with a 3D printed piece of material. It can happen with focus for software. So what I thought I would do is just share over the next half hour or however long it takes semi-organized, semi-random observations that I've seen over my career about big impact, like asteroid hitting the Earth level impacts in tech. And what did it mean? And what would the winning play have been at each of those times? Because we have 1 or 2 of those coming up right now. And I know everyone's talking about it, so I'm just going to talk about it a little more. But all I'm hoping to leave with is either reinforcing things you already believed or making you serious about things you thought might be right. And that's it. I can't teach you quantum computing, oh my God. There's some other mirror me in some other place trying to do that. And artificial intelligence is too big a topic for 2 letters. And to dive in and tell you the difference between machine learning and a large language model what I'm hoping to accomplish today. Okay, graduated from. Here's a little bit of context. I did graduate in 1985. Lived in the artist formerly known as Mulder Hall, which is now where the Spartan Village or whatever, I don't know what it's called, but the high rises are. But it was the bricks. There was some brick dorms there. Student loans. You know, I just took out student. Anyways, it was less expensive, probably even inflation adjusted. But I took out student loans to pay for the dorms and the school. Worked on weekends. Once I moved off campus, I had to work on weekends some more because I now had to pay my own. So I basically put myself through. I wasn't abandoned by my parents, but I was the first child from my family to ever graduate college. So the idea of, so for example, I was getting recruited at MIT, Berkeley, San Jose State, other places. I don't know if I could have gotten into MIT or not, probably not. Look at me, right? But I ended up choosing the school that just felt most like home, where I could live and afford to live on campus instead of not. And so just based on that, I came here. And what I'll tell you after 40 years, you can come out of here at San Jose State, the only thing missing is the alumni network ready to come hold your hand and give you an entitled point of view that says, I never have to work for a company, I only start them. Okay, so you won't get some of that. But I've had Harvard graduates work for me on the business side, MIT graduates work for me on the business side, Yale, Berkeley, you name it. So don't be intimidated when you look around you, right? All that matters is what you know, and you're running the same material here as anywhere else. The only thing you're missing is maybe there's some higher competition. Maybe. There's more nepo too, there's more entitlement, but there is competition. So if you are cream of the crop, if you were A students, you have to push yourself. Okay, because you have just a little bit less push. And for me, I didn't have a push at home because they didn't know, they were already proud. You know? So anyway, came here, sent bachelor's in computer science engineering, which at the time was 50% software, 50% hardware. And of course, I had to take all the basics, hardness testing, materials, all that stuff. I'm a little bit of a mishmash because I've got big company experience, which is how to manage large planets with planetary pull and large gravity and so in other words, large groups of people, large groups of projects, and get them to all kind of move together in a direction and an outcome that you're trying to drive, and then how as an individual to be successful in that. Only after you figure out that do you get to work on whatever it is your assignment is. And I've also been in startups, which is the whole opposite. You have to convince some investors, which would be a room about this big, intimidating as heck, that your idea is not only good, but you'll be better at building it than anybody else will. But you completely don't have to worry about any of that other stuff. Budget meetings happen every time you go to raise more money. But other than that, not really. You don't have to worry about the politics of that group over there trying to launch a project that's going to compete with my project. How do we prevent them from, none of that happens in a startup. But you also end up having to do everything else. And if your startup doesn't work, there's no safety net. Poof. So I've got this interesting combination here, and I really did it small first. I was an individual contributor engineer at a big company. Then I went and did startups, so I was clueless. Just did my job, and I was really happy. Went and did startups. And what was nice was that when I then went back into big companies, I knew how a whole company worked because I'd done a startup. So the person running customer support sat next to me here, or maybe it was me. I was running engineering. I was the CTO, typically, founder CTO, which meant I was the CEO's sales engineer. In other words, it's called an SE. Every meeting that the CEO went to, I would come with. Okay, so we're technical questions, right? So that's that. So end of last year, I finally retired. And now I'm just trying to figure out, but I'm not ready to go out to pasture, so I'm still working, and there's books written on this, what do you do after? Because all of this has been, how do you accumulate more money? How do you accumulate more network connections? how do you know. Now, you end up having to step back a little bit and say, wait a minute, I'm going to invert all that and go from a, I don't know, if I was a transmitter before, I'm a receiver now. Maybe it's the other way around. But that's what I'm in the middle of right now. So if you see me acting a little, having a little weird tick or something, I'm in the middle of a transition. And always happy to help here anytime I can. You know, I think the answer ends up being, I want to stay involved and I want to help you. Okay? So what I wanted to do today was talk about is there anything going on right now that you, as I call you emerging engineering talent, whether that's year 4s, I don't know which, how many, year 4? Or seniors graduating, getting ready to graduate? 3? 2?
Graduate students, maybe?
Yeah. Graduate students. Oh, okay, all right. Is there anything that this group here can do to improve your odds of success? Whether it's success getting a job, whether it's success getting a job that was you wanted, deciding whether you want to start a company or go work for a company, go be a PhD, or maybe I'll just plant a couple of thoughts about how things could work once you're in a company and you start wanting to manage your career based on a vague memory you might have of this old guy standing up in front talking about what it was like when we went from mainframes to mini computers, or what it was like when we went from mini computers to PCs, or PCs to, or what happened when the World Wide Web. There used to not be a World Wide Web. President Bush II called it the Google, because he didn't know what Google was, right? So I think I'm going to try to learn to use the Google. You know, people kind of make fun of him, but he was really smart. I mean, really smart. You don't get to president. Oh, okay, I don't want to talk about that. But at the time, it was really hard to get to president. But, you know, so what I'll do is give you a quick, and I think, by the way, the answer to this question is yes. You're actually being born into an era, born meaning emerging from your educational cycle, that is one of those transformational moments. So, cheating, the answer at the end is yes. I found a quote. There's a guy named Richard Branson, rich British guy, who founded Virgin Airlines, Virgin Starlink, which then went out of business, some other things. But his quote was, business opportunities are like buses, there's always another one coming. Well, I shifted it. Shocking technology shifts are like buses. So it is a cycle. But the cycle's kind of getting faster. Okay, from mainframes, no computers to mainframes. You know, I don't know, Grog, Rock, Hammer. Okay, yeah, that took 100,000 years, 50,000 years, whatever. Mainframes to mini computers, 20. Minis to PCs, 5 or 10. PCs to cell phones, another 5 or 10. So things are happening faster. And AI, used to develop AI, is going to cause this weird, semi-recursive, mind-twisting acceleration again. And quantum computing, as it starts to happen underneath it, is dangerous. Okay? So, yes, another bus will be coming, and maybe they're coming faster, you guys, but if you don't take advantage of this one, I think you're left behind. Because I think the next bus will leverage this bus. Okay? So, quickly, or semi-quickly, I've never been accused of quick. Here's the ones I've seen that I could think of off the top of my head. And I'm not viewing this academically. I didn't put it on 3 axes, leveraging anything. I just sat around, with the Coke on the deck and said, what did I see? And when I first graduated, mainframes, I was in my first company was Memorex. Memorex competed with IBM on on storage for mainframes. I was a firmware engineer for string controllers. What's a string controller? I didn't know what one was either. There was no course in string controller. I thought maybe I was going to be working on word processing or something because there was this new thing coming along called mini computers and get time. And it turns out it was strings of disk drives. Okay, and these disk drives were this big. The mainframe was the size of that wall. Even when I went in as a trained storage engineer to work on a new product, I wasn't allowed to operate the operator's console for the mainframe. You had an operator, which was a human being. And only they could put fingers to keyboard to operate the mainframe. Okay? So I came in and I would have these, my tools were an oscilloscope and a Contron analyzer. We were using bit slice processors. We wrote our own assemblers. We wrote our own compilers. When you had a problem, you had to check to see if it was a bug in the assembler or was it a bug in the compiler before you could get around to if it was the bug in the software that we'd written. And it was real time because you were looking for this rotating disk and trying to figure out when you could lay patterns down and then take patterns off. That was a long time ago. That was state-of-the-art stuff. I did get the benefit, because mainframes had to be ultra reliable, I got the benefit of never ever learning how to write a line of code that said, can't get here, throw an exception, right? Just throw an error, trap out, whatever. You just can't do that on a closed loop internal system that's expected to be 4 nines or higher, or 5 nines. Every line of code has to end with a path to a recovery. I often called storage engineering, we're building these gigantic error handlers that in the absence of errors retrieves data for people. Now things have changed a little bit, or you can use other people who've been building that for you. But I ended up, I felt becoming a better engineer because of the first job I took, because you just couldn't take shortcuts. Next evolution, so mainframe to MIG. This was also, if I really dove into it, the emergence of Unix. Many computers were open, meaning it wasn't the closed IBM VMXA or MVS operating systems. You started getting Digital Equipment Corp, DEC, Unix. You had Sun with Solaris. And then later on, of course, that became Linux. And Linux is still going strong. Then the PC got invented. So that was it. So whole careers happened in this name, and fortunes were made. Companies flourished, companies died. Eventually, and the companies that didn't transition died. Then the PC came along, the IBM PC, then you had Compaq, MS-DOS versus CP/M versus DR-DOS and some other ones. But these were tectonic shifts for engineers. They were tectonic shifts for nerds. There were tectonic shifts for how IT departments operated. But I don't know for sure that these were tectonic shifts in society. A lot of people didn't have a PC even when the PC came around. It was just nerds like me that had one in the garage, right? And Macs showed up right as I was graduating, and you used it to write your essays. Even though it had BSD, Unix running underneath it, wasn't really used in engineering for development. In fact, I know PDP-8s or PDP-11s downstairs that we were using. But, well, this building exists. But here, it started becoming a society impact thing, including where do you want to work as an engineer. So if engineering is an iceberg, most of the iceberg was under the water here. Started becoming 50-50, above the water and below the water, for lack of a better analogy, here. So the internet and the World Wide Web started making the need for more and more of this in order to support the emerging digital storefronts and digital footprints that had to exist for every company, and there was a democratization of knowledge happening. You could get into a lot more knowledge. It started academic, but it got bigger. Oh, I need a data sheet from that thing I needed a long time. You used to have to write a letter or make a phone call, or now you could actually search. The first browser I ever used was a terminal-based browser, meaning ask characters, ABC, asterisk, caret, So between the internet and the web around it, this created, first of all, it took minis and mainframes, combined them into Sun Microsystems servers, for example. And the world got rich on networking and servers here to provide the computing backbone that thousands of these would be ganged together to create this backbone that could support the proliferation of web usage, which kind of sounds like just a new way to build a mainframe to me. So there aren't that many new things. So what's the learning? There aren't that many new patterns you're going to see. There's going to be new implementations. Centralized computing. How do we get so much computing that it can power the new needs? Well, it used to be mainframes, now it's cloud. But it's kind of centralized again. So anyway, next was smartphones. You may not think of it as a big deal, or I don't, we're so used to it now. But now, massive compute, interconnected reliably, grown so huge in the cloud that everything can be accessed, and devices to actually access it through the cloud, so universal that you can get it anywhere you want to. I'm not wearing an Oura ring, that could be, right? Pretty soon there'll be implants. The Matrix, nothing's new, everything's just cycling. These were you could probably do a case study on each one of these and how did these change society, what did this do to engineering skills. I know that my eldest son, 3 sons, he went into engineering. He's mini me, but way smarter. Number 2 teaches history at high school in Gilroy. Number 3 wants to be an actor on Broadway, so he's in New York City. But the software engineer happened to come out of college at one of these tectonic shift periods, where search was becoming big. LinkedIn was kind of going, and he became an intern at LinkedIn, got hired into LinkedIn, and he's still there 8 or 9, maybe 8 years later. Turning 30, which brings me out. So the skills he needed to learn were full stack, for example. Search optimized. How are people going to, now he's lucky, when you go to LinkedIn as an engineer, you know what people use LinkedIn for. So you have some context into what you're building and why. Whereas if you went to work for a medical company, you might have no idea what this means, because what do I know about hospitals at your age, right? So I saw these 5 with kind of a sine wave kind of going back and forth between centralized and decentralized compute and centralized and decentralized access. That's the boring part. Now, I think the next 2 are, and this is like a Captain Obvious statement, but I'm going to say it anyway. AI and computing. What I want to talk about a little bit is AI for AI's sake, just knowing the buzzwords and can cut it. Okay. Quantum has always felt asymptotic. You're always halfway closer, but you're never actually going to get there, right? It's just an infinite search. I actually think it will come in your career. And it might even come in a decade, because AI is going to be working to help solve the problems and accelerate the pace of how do you harness counterintuitive laws of physics to try to create deterministic results that can help you then model systems that aren't deterministic. So it's a brain twister. It's really, really weird stuff. Yeah. I think what I'm going to spend the rest of the time talking to you about, and ask questions along the way, or stop me if you think I'm smoking something, is why I think that these are the things to focus on. And at altitude, not at detail. I can fake out non-engineers at detail. I can't fake out engineers at detail. When you do big companies, you become 80% of your time. Mostly talk about artificial, but I want to put a little appetizer in quantum. Okay? So the first first thing is AI is not, there's not just one thing called AI. So in the Department of Irony department, I went to get a definition of the kinds of AI and I asked ChatGPT. So the source for this slide is the accumulated knowledge as documented on the internet of the human race, as contextualized by large language model learning with ChatGPT. And what you get are 6 different categories. Now, mostly what we talk about, and again, I'm not claiming this is definitive. I don't know that this is what I could write a textbook around, okay? But this is what ChatGPT thinks. And it's still, I think, useful. Narrow AI, designed to perform specific tasks such as image recognition. Show them a picture, where's the trumpet in the orchestra? You're using a different kind of technology than the semantics and contextualization of language that you get in patterns that you get in generative AI. And a lot of this is now being, artists formerly known as deep learning, machine learning. These techniques are still alive and in fact critical to what's happening inside of each of these AI models. So if you ever hear somebody say, oh, AI was the thing after deep learning or machine learning, neural networks. No, it's made out of those things, okay? Then you've got generative AI. Generative meaning it learns, you have a system, a model with the data that's trained it, to learn enough about all the things that have happened already that you can ask it a new question, and based on that, it can generate a response that's consistent with all the kinds of things it's seen in the past and therefore sounds like intelligent. So it's not actually thinking, but it's really getting good, together with some of the speech management types of AI, to start passing Turing tests. And Turing test is a scientist named Alan Turing, who short version would be the way to test whether you've achieved artificial intelligence is if the artificial intelligence cannot be indistinguishable in its responses to queries from a human being, basically. I don't know if I would pass an essay to that, but so passing the Turing test means fake out grammar. Okay? Discriminative AI, that's the object in the image example. General AI, now we're starting to try to generate intelligence, like self-awareness type stuff, right? So general AI wants to start doing things that are widely, not just micro-focused, but to generate similarity to human intelligence, self-aware, self-explanatory. This is also scary. And artificial superintelligence, which is just becoming faster and better at anything human can do. These are all, I think, if you go on to PhD stuff, maybe this is what you work on. I don't know if this is really real right now, okay? But these kind of all. So what's my point on this slide? There are more to AI than Gen AI. But Gen AI is hot right now because ChatGPT and its natural language interface and the fact that it trained on such a large model and they had the money for the compute to do it, made it approachable. By the way, Alexa just announced that they're finally going to be migrating their intelligent assistant to run on, it's actually Anthropic, I think. So they'll run whichever LLM is the most advanced at any point in time. So they're basically building a layer of software that lets them put all of their speech processing and querying onto a wrapper that will then contain whichever company's model and generative AI implementation becomes most powerful. Whereas like Google's making their own, and they're betting it all on what they've built in-house. Microsoft's building their own, what with their investment in ChatGPT, and they're going to do it all in-house. Alexa's coming, Amazon's coming along and saying, you know what, there's companies that are going to try to build the world's best ChatGPT and Llama 10 and whatever they're going to do. We'll just ride that. Okay. you might hear a couple of terms. When I was at HPE, the last project I had at HPE was to ship a product. Where's the word first? Product naming company. There used to be a joke about it. Like, we wouldn't call it sushi. We'd call it, raw fish and rice or something. I forget the exact, but we just described it, and that's our name. So private cloud AI. But it was a combination of the hardware stack that could carry enough GPUs to do the processing, a software stack that enabled you to take all the open source tools that a company would want to use and put them together so that they could put their pipelines together, and then put it on wheels and roll it into your data center that you can use it, because there are a lot of privacy issues coming up with AI right now. So in enterprise, what you're finding is that does Shell Oil really want to put its data in the public domain so that Exxon can benefit from it? Can Coke, Pepsi, you get it, right? So what they're doing right now is they're actually bringing things out of the cloud and back on-prem because they're not sure there's a way to protect their data. And we're starting to see that actors are unionizing, they're union actors, and well, I'll just use actors and actresses, whatever. The acting unions are now saying, you know what, if you've trained voices on all the movies ever made, so that you can now make a movie that doesn't require actors, shouldn't those actors that you trained on get paid? How's that work? So there's all kinds. So a lot of these large enterprises are now turning to companies like HPE, Dell, IBM, and saying, you know what, I think I'm going to take my most important data, I'm going to keep it on-prem. I'll train just on my data. Okay? So they're now doing their own training of the models, of the large language models, and sometimes they might even modify the model itself. Okay? So that's happening, large language models. Large language models is also basically, and this is wrong again, but think of it as the model trains on vast amount of written data primarily for the purposes of being able to understand the patterns between different words and combinations of words in context to other words and combinations of words at larger and larger apertures. So it can so it can start saying, I see how those things go together. I don't understand anything, but I can, greatest parrot of all time, I can mimic predictively where you're probably headed with that. Okay? Now what happens, another big topic in enterprise, for what it's worth, is RAG. Okay? Now I don't know if RAG comes up here in anything you guys study, but retrieval augmented generation. It's basically, here's the problem. I work for Exxon, I pretend I work for Exxon Mobil. I've got my ChatGPT based systems brought in-house. I've got a whole bunch of tools I put together with my engineers that I'll show you about in a minute. And I've now got this thing humming. But the problem is I couldn't just train it on what's coming out of the wells. That's just deep learning. But I needed to every paper. So what I did was I learned on every paper ever written about geophysics in the internet. I then took all the work that I've done with my own data. But the problem is if you ask it a question, it's likely to come back with a general purpose oil and gas answer. But what if you're in upstream research, okay, which is before it's been processed? Okay, downstream's after it comes out of the ground. So you're upstream. I'm looking for the next Permian Basin. You apply logic specific to your use case after the general purpose response comes back. So in the example I used, I got it a little tricky because it was already specialized because it was oil and gas. But if you needed an even more specialized, I'm upstream, you would apply RAG in front so that your answer would then be contextualized into the business that you're trying to solve. So for if you were using the public models and the public training, you would need it, or else you might get an answer that was completely wacky because you were really meaning to ask about, I meant in France. So these are the two terms you'll hear, and the way to look at it from a distance is, well, this is more definition. RAG is used to give an industry context or a company context to a query. Yes?
I noticed something similar, like on Google, when I type, like, I guess an example would be like, how there's like, I think there's like a RAG implemented, so I only get like US-based results, whereas, is that like already a thing? Or?
I think, so now we're on the border of what I know and what I suspect, okay? But I believe the answer to your question is yes. Or if it's not RAG by definition, it's conceptually the same thing, which is they can't. So RAG is post-processing. Okay, so the query spits it out, and then if you have a RAG step, you would apply it before, or maybe I'm talking to it, But at a minimum, it's an example of post-processing, because they don't have a data set that's only, you could, but they probably don't have a data set that's only US, or they trained on everything that's ever been, right? So then they have to apply it afterwards, right? Based on, so it's probably this pattern, okay? Same thing's happening in medicine, where they're realizing that confidentialities are being broken inadvertently, and if you try to fix it in the neural nets and the logic of the model and the training data, it's really, really hard to. Root cause analysis in this is a really hard thing. So sometimes you just put something on the backside that's like guardrails to keep you from breaking any laws. So a lot of, post-processing protective steps for industry specific. And do your own research, come back and tell me, Chris, here's a better way next time you do this to teach it, because I'm not a teacher of this, I'm an observer. Okay. So that's what AI is. Those are what tectonic shifts are. What is it that I'm starting to see about AI that makes it a little bit different? Well, one of the things I'm seeing, and these are from McKinsey studies, and here's a list of of many different areas where there's demand to use Gen AI. This is the number of people in each of those areas who are thinking, yeah, AI is cool. And this is the amount of money, GDP, that's the wrong word, but here's the amount of money that's going to be spent in each of these areas. So the first takeaway, as far as I'm concerned, from this slide, is that AI is applicable, not just for software engineers. Sales and marketing comes in number one in terms of dollars impact. Think about how a trained AI user that's also central casting sales guy, in other words, smiles and it sparkles, can do with these tools to get to know you, what you're doing, where you went last week, what you've been thinking about doing, what that means, what everybody who's kind of like you has ever done in the history of the world, so they know what to tell you next. $1 trillion. Okay? I don't know what the time frame is, but it's not like in the next 20 years. Near term. Software engineering. My son, the LinkedIn software engineer, just getting ready to go staff. Doesn't trust AI-generated code at all, but he has to use it to make it ever-accelerating timelines, but mostly as a starter. At least I think that's what I'd be doing if I was, right? Because I don't know if this kid's recording or what. But customer service is going to use it. Hardcore R&D is going to use it. Supply chain. Supply chain is buying, if I was a chair company, supply chain is where do I get the legs of the chair? Where do I get the fabric for the chair? Where do I get the wheels, right? So supply chain needs it. Legal. Imagine if you say, I need a contract with this new company, we need to be able to do this, read every contract ever used in your industry and history, and then said, okay, here's what you need. That's what they do anyways, you guys. There's not really much new. Operations, finance, HR, procurement, IT, strategy. every single component of modern enterprise is going to benefit, no matter which of these departments you work in at a large company, if you're not getting on board with the things we're talking about here today, you're going to get left behind pretty soon. Yes?
I have a question. What do you think it means that legal risk and compliance is the one dot that's below 50% positive outlook?
Well, I can only speculate.
Yeah, ask you what you think, so, yeah.
Well, I haven't seen the survey, so I'll answer it a little differently. I'll tell you what I was seeing in corporate America. And what I was seeing was a lot of churn from a legal perspective and the implications of that. So I did see a lot of concern about AI from legal and compliance, not related to, can I use AI in my job? I mean, not directly related to, how do I write my next contract? The noise that I was hearing was around, and this isn't just from legal and the company I work for, this was watching the behaviors of companies we would sell to, was concern about privacy, for example, concern about preserving intellectual rights, concern about accidentally becoming read into someone else's intellectual property by using a large language model that happened to be trained on it. Okay. So there was a lot of fear, uncertainty, and doubt about AI when it came to that. I don't know if that helps or not. And then over here, same study, and these are all available on the web. You can just go read it. It's the only reason I used it here. And this one, I'm making my slide, so it's not, obviously didn't capture that good enough fidelity. But for me, the big takeaway here is that companies are investing in Gen AI, but have not yet achieved maturity. 22% know they want to get, 92% know they want to get there, but only 1% feel they're mature. That 1% is probably true. Okay. So to me, that translates to if you're going into the workforce, you're going to be going in at a time where one of the problems they're facing is an impedance mismatch between what they have and what they need in the area of AI skills. In all these disciplines. So if you come in from an interning standpoint or an interviewing standpoint and don't just have an ability to fake it, but actually have invested the time to have opinions in the AI stacks and have a fluency in talking about where in general they're useful and where they're not, you are going to become a hot commodity. I would be that way, or I still am in a higher position right now. Okay? And this just reinforces what I already said. Again, here's my excellent, I had my iPad out, I said, this, right? This. I wasn't sure what the audience would be like. I wasn't sure if it would be, me and the dog in the auditorium. But I think what's happening, and the reason I left the slide in here is even though I'm talking to an engineering team, you're going to be building for these use cases. So even if you're not one of these use cases, you're building for one of these use cases. And back to my comment earlier about if you don't know what you're building for, how can you possibly? A product manager will never give you enough build instructions for you to really know what you're building. Build a bike. If you've never seen a bike, ridden a bike before, and you get this product manager says round thing with long skinny things connecting it to the middle, who knows what we'll build? But if you've ridden a bike before, you get it. So even if you're here, even if we are this robot in the machine, we're building these awesome systems, How do you make art-based AI? How do you build the world's best translator? I'm talking to a company in Germany right now about it's a consulting, and we're talking entirely through Google Translate. I hope it's working out. Medical insights. You know, this AI for the purposes of determining whether you're at high risk for cancer. Financial forecasting. Will AI trading take over the world? AI versus AI. To me, this scares me kind of like war. Anyways, you can go around the table, you get it. So my message here is really, if this was a general audience across the person, would be you probably need to care, not just the guys who do with binary. Okay. So, more specifically, from an engineering perspective, this is an example of what if I were a hiring manager, would want to be able to put in front of you and say, I'm trying to solve this problem. Which of these tools do you think would make sense? Or I would expect you, if you're telling me you're coming out AI aware, to have a knowledge of these different areas, at least one player in each area. And the relative, and that, this is a little bit of a shock and awe page sometimes. To some people it's like, and this is a few months old, so it's probably outdated, okay? But whether it's GPU providers at the bottom and the hardware providers that make them accessible, like the company I used to work for, that's great. But what model are you going to use? Like I was just talking about Anthropic and how it's used. And it basically says, okay, now to link to the right one's available to you. Models. Models are small. The data that allows them to get better and better at they're not small, but compared to the data they train on, they're small. But they have to be version controlled, they have to be managed, they have to be, people are constantly modifying, they have to be life cycled. There's open source models, there's proprietary models. What do you do about models? And then inference. Inference is just decisions being made based on those models and what's been trained into them. What are these companies doing there? How would you use them? Okay? And then you've got, there's more, training, fine-tuning, then data. We could do a whole session on reemergence of data. You know, Gen AI is only as good as the data it trains on. The amount of data that it has to train on is huge. And if everybody's going to start creating their own copies of everything the world's ever done, you start to have a need to build new data centers. These big companies, Microsoft and so forth, they're actually talking about nuclear-powered data centers. Right? So then deploying and observing. This is an example of the effort I believe you need to put in to AI if you want to come out of here and have that conversation with one of these companies to convince them that you're part of the solution to their I'm only 1% ready and I'm 92% sure I need to be there now problem. You can speak with some contextual intelligence. Even if you're a new grad, well, you know what, I did a little project on the side where, it'll help. And sorry, there's another slide just like it, okay? This is still on the engineering side, but here's another example where it's focused on open source initiatives. Okay? It's the Wild West right now. There aren't standard terms yet. There isn't a standardized set of stack definitions, okay? But it's starting to come into shape. So between those two slides, like when I first came into storage, we had versions of these slides, right? What's your substrate? If I went way back, right? Or when I started writing storage, things like NetApp and stuff, you would have an entire set of There's an equivalent amount of complexity. What's my point? There's an equivalent amount of complexity in almost every industry you might go into with its own terms. And it's very, unless you decide to become an AI developer, a developer of AI, then I would expect you would not end up being able to be PhD level smart on a slide like this. Where I just said, close my eyes, pick one of you, tell me about feature base. Right? But if you're building AI, you're going to know that. It'll just happen. Okay? But if you're one of those people that I circled in that other slide with my stupid little pen, right? What you need to know is which of these you might start with if you were wanting to use the knowledge you have of AI to help you get to that answer in a way that closes that 92% to 1% gap. You have to know enough. You know what? What AI development platform do you use? Allegro. Oh, well, let's say all you know is Domino. You can actually maybe say, well, how's that? Is that like Domino? Well, you just kind of pass the test. Okay? At some point, you're going to become a leader in your organization. You're going to make recommendations on AI platform. But in any case, it's intimidating. But if I were, the old song, find you then what I know now. Anyways, if I were to go back in time and be in your chair, this is where I'd be spending my free time. It's studying charts like these. But I can't recommend you pick one of the two I picked. Okay. But if you don't find anything better, you can go. Okay. But what if you're in marketing? Even if you're in marketing, here's 10 applications. Again, I didn't attribute it on the slide, but this comes from public sources. I don't work anywhere anymore, so everything I got is public. But whether it's online advertising, personalizing the user experience, get ready for phishing and spam like you've never seen in your life. Okay? AI-powered chatbots, all the way around. There's a chart like the one I just showed you that is marketing specific about which tools you would need to know if you were going into a marketing job where you would want to profess knowledge. And it looks kind of like this. Okay? So if any of you are actually secretly marketing majors and you're thinking about going into marketing, when you go into that interview, know something about HubSpot. I don't know anything about HubSpot. Really, I know nothing about HubSpot. But if somebody called and said, Chris, I need a little time, help us with our marketing strategy for AI, I'd go read these. Because I already know some of the stuff that I've shown you, I'd go read them. Sales. Oh. So here's the guy I was talking about. I just picked some central casting sales guy, right? I mean, would you buy a house with that guy? I'm not sure. But the next generation of that guy or gal is going to be enabled by their brain. Okay? Every one of these is a little bit different, but you have to, you don't have to. I would encourage you to learn the ecosystem, not just the underlying technology concepts. If you learn the ecosystem, you're going to start having a common language with other people from other schools, or people that you end up working with, or even just friends that you meet that are studying this. And this, it's really these, you learn the concepts here, they're meaningless, other than the fact that they have prepared you for this. But I learned how to learn in college. I learned enough foundations to have a scientific method thinking. I learned enough to know how to finish a project and not just start a project. I learned enough to be intellectually curious and how to sort of focus that into delivering something. Okay? But at the end of the day, what I learned when I went into the real working world was that if I didn't have that, I'd never figure out what to do next. This is what you got to do next. You'll be using this all the time, or or in sales, or the thing I had up 2 slides ago, if you stay in tech. And it's moving fast. I'll wrap up. I just wanted to say one thing about quantum. It's been in the news lately. It's been in my science fiction books for 20 years, okay? It's been in the news lately. Because Microsoft just figured out how to put some quantum computing on silicon. And Google's been putting together some, I mean, he's happier inside than he is on the outside on that, but they've been putting together some quantum work itself. We got to be careful about the hype a little bit, but AI is being used to help develop quantum, so things are starting to get, cursives don't work, but they're getting iteratively faster, generation to generation. And in the case of Microsoft, I believe what they proved with this chip is that they've been able to create a theoretical type of particle that can surround a qubit to help stabilize a qubit. Qubits are the quantum atom that possesses more than 1 and 0. In fact, I don't know if it's infinite, but I'll say infinite states. Again, I'm way out over my skis, okay? But in order to get even 1 qubit, you got to invent these new techniques. The value of a qubit changes upon observation. So how do you make them measurable? But what companies that have deep pockets like these two are doing, and I don't know what's happening in academia.
Elaborate on you.
Perfect. Is that the really smart ones are putting together the building blocks. The next thing will be prove you can create an 8-qubit that actually didn't take this whole building, which is kind of what this does. So, and build it in a mesh that's simple to scale, and but when it shows up, it changes everything. AI on quantum scares the beast. So, in summary, this is unreadable, so I'll read it to you. Is there anything we can do right now to be like even more awesome than we already are? Yes, those things I was just talking about. If you're in AI, learn what I talked to you about. If you're not going into AI, or if your friends are not going into AI, tell them you need to do a mini-me version of what I'm doing. You guys will all buy houses with ocean views or something. If there's one thing, you only do one thing, study up on prompt engineering. How to query AI. You can make generative AI do more things than it was really thought that it would be able to do if you know how to ask it. So if you are really good at asking these LLM trained models the type of code that you needed to write for your work, if you're better at asking questions, so if I were to start somewhere, I'd start there. When the Google first came out, I got really good at queries. Because if you didn't ask it the right question, you didn't get any answers, right? It's like that. From a quantum standpoint, if you're hardcore, it's a great place to spend the next life, the rest of your life. In theory, there's going to be chips that are going to be needed. There's going to be a gold rush arming quantum. But I can't be sure when the timing is. It's sooner than you think, but it's probably not quite as soon as they want. So, otherwise, do all of these things, all the things we were talking about on the AI open source charts, because when quantum comes, it's going to make all that stuff even more important. It's all going to become less powerful. So that you will be in a position, you're a trained pilot, you have a new ship underneath you with a quantum drive. What a great time to be a pilot. In this example, trained AI. You can ride the quantum. So I would keep that in mind. And finally, from a practical perspective, big companies know this is where they're going. If they believe they're talking to someone who can help them get there. Yeah. So for what it's worth, like I said, you probably learned all these things before, but from my perspective, having done this for a long time, this is one of those buses that comes along, and it's a combination of tectonic shift technically and tectonic shift society-wise, which means you'll be able to use the skill. Thanks for giving me your lunch. You know, or I don't know when you woke up this morning, maybe it's breakfast, but thanks.